Om Swastiastu. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera untuk kita semua. Shalom Namo Buddhaya, salam kebajikan, salam harmoni. Hello everyone. In advance, let me introduce myself. My name is Rara Septiani with number ID of 211301192, student from the Mathematics Department on Ganesha Education University. So, I am here to explain the material about squares and series. Do any of you know what a square is or what a series is? I'm sure some of you already know in general and some don't, or maybe some of you already know. So I am here to help you learn what squares and series and their parts and ways of solving of some types. Do not forget to listen to them. First, I will explain about the squares. What is a square? It is a set of numbers which are written in some particular order. For example, take the number 1, 3, 5, 7, 9, so far. Here we seem to have a rule. We have a sequence of odd number. To put this another way, we start with the number 1, which is an odd number, and the nth successive number is obtained by adding 2 to give the next odd number. Here is another sequence: 1, 4, 9, 16, 25, so forth. This is the sequence of square numbers. And this sequence 1, negative 1, 1, negative 1, 1, negative 1, so forth, is a sequence of numbers alternating between 1 and negative 1. In each case, the dot written at the end indicated that we must consider the sequence as an infinite sequence so that it goes on forever. On the other hand, we can also have finite sequence, the numbers 1, 3, 5, 9. From a finite sequence containing just 4 numbers, the numbers 1, 4, 9, 16. Also from a finite sequence, and so do these their numbers 1, 2, 3, 4, 5, 6, so forth to n. These are the numbers we use for counting, and we have included n of them. Here, the dots indicate that we have not written all the numbers down explicitly. The n after the dots tell us that this is a finite sequence and that the last number is n. Here is a sequence that you may recognize: 1, 1, 2, 3, 5, 8, so forth. We may call the first term in a sequence u1, the second term u2, and so on. With this same notation, we would write un to represent the nth term in the sequence. So, u1, u2, u3, so forth to un. As another example, we could use this notation to represent the rule for the Fibonacci sequence. We would write un equals u times n. We would write un equals u and negative 1 plus u and negative 2 to say that each term was the sum of the two preceding terms. Next, I will explain what a series is. Something we obtain from a sequence by adding all the terms together. For example, suppose we have the sequence u1, u2, u3, so forth up to un. The series we obtain from this is u1 plus u2 plus u3 plus so forth up to plus un. And we read as n for the sum of these n terms. So although the ideas of sequence and a series are related, there is an important distinction between them. For example, let us consider the sequence of numbers 1, 2, 3, 4, 5, 6, so forth up to n. Then S1 equals 1, as it is the sum of just the first term on its own. The sum of the first two terms is S2 equals 1 plus 2 equals 3. Containing, we get S2 equals 1 plus 2 equals 3. S3 equals 1 plus 2 plus 3 equals 6, and so on. Since the explanation of the sequence and series has been completed, I hope that from the explanation above, the difference between the sequence and series can be understood. Now, I will explain some types of sequence and series. There are 4 types of sequence and series, namely arithmetic, geometric, harmonic, and Fibonacci. On this occasion, I will explain more deeply about the types of arithmetic and geometric progression. First, I will explain about arithmetic progression. An arithmetic progression, or AP, is a sequence where each new term after the first is obtained by adding a constant d, called the common difference, to the preceding terms. If the first term of the sequence is a, then the arithmetic progression is a plus d, a plus 2 times d, a plus 3 times d, so forth, where the nth term is a plus n negative 1 times d. We can use algebraic notation to represent an arithmetic progression. We shall let A stand for the first term of the sequence and let D stand for the common difference between successive terms. For example, our first sequence could be written as 1, 3, 5, 7, 9 in the example pattern given. So you get a pattern like the following: 1, 1 plus 2, 1 plus 2 times 2, 1 plus 3 times 2, 1 plus 4 times 2, so forth. And this can be written as A plus D, A plus 2 times D, A plus 3 times D, A plus 4 times D, so forth, where A equals 1 is the first term and D equals 2 is the common difference. If we wanted to write down the nth term, we would have a plus n negative 1 times d. Next, I will explain about geometric progression. A geometric progression, or GP, is a sequence where each new term after the first is obtained by multiplying the preceding terms by a constant r, called the common ratio. If the first term of the sequence is a, then the geometric progression is ar to the power of 2, ar to the power of 3, so forth, where the nth term is ar to the power of n negative 1. Let us write down a general geometric progression using algebra. We shall take a to be the first terms as we did with arithmetic progression. But here, there is no common difference. Instead, there is a common ratio, as the ratio of successive terms is always constant. So we shall let R be this common ratio. With this notation, the general geometric progression can be expressed as ar to the power of 2, ar to the power of 3, so forth. So the nth can be calculated quite easily. It is ar to the power of n negative 1, where the power n negative 1 is always 1 less than the position n of the term in the sequence. In our first example, we had a equals 2 and r equals 3, so we could write the first sequence as 2 times 3 2 times 3 times 2, 2 times 3 times 3, so forth. In our second example, A equals 1 and R equals negative 2. So that we could, where it as 1, 1 times negative 2, 1 times negative 2 times 2, 1 times negative 2 times 3, so forth. Next, there are other types of sequence and series, namely harmonic sequence and Fibonacci number. Harmonic sequence, a series of number, is said to be harmonic sequence if the reciprocals of all the elements of the sequence for an arithmetic sequence. Next, Fibonacci number. Fibonacci number from an interesting sequence of number in which each element is obtained by adding two preceding elements and the sequence starts with 0 and 1. Sequence is defined as f0 equals 0 and f1 equals 1 and fn equals f and negative 1 plus f and negative 2. Okay, well, that's all the material that I can describe on this occasion. Now, do you understand about sequence and series, or there are still confused? If there are still confused, you can contact me. Yes, contact in below. Maybe that's all from me. Thank you to all of you who have listened to and watched this video from beginning to end. I apologize profusely if I make a mistake intentionally or unintentionally. I hope the material that I describe on this occasion will be useful for all of you in the future. Once again, I thank you very much and see you soon. Finally, I say, Om Santi 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 Om. Wassalamualaikum warahmatullahi wabarakatuh. See you guys. Goodbye.